This is my final elevator controller circuit. So here we have the 16 buttons that are the floor that you want to go to. And then over here is the LED that shows the 7-segment display that shows the current floor, as well as a 4-bit of LEDs that show the current floor. So as you can see, the elevator is currently on floor 1. So when I input a value, it will take that into an inverter first and invert it, and then it'll take it into a priority encoder, which turns that 1 out of 16 into a 4-bit binary representation. And then it'll take that into an enabled flip-flop, which stores that, or stores it so that with the clock it keeps that until a new input is given, if a new input is desired. And then that input goes into a comparator here, which compares that value with the current floor, because the elevator outputs a floor in a 4-bit active load number. And so it compares that, and then it decides whether the motor should go up, down, or stay at the current level. And then that's reflected in these output wires here, which then tell the motor of the elevator to go to a certain floor until it reaches the floor that it wants to go to. And so this is where the elevator actually tells you what floor it's at. It goes in here, and there's a enabled flip-flop here also, where if the elevator is currently at a floor, it will register that floor. But then if the elevator is no longer at a floor, then the enable will go high, and so it'll keep whatever the last floor was. So let's say I press, this is 4, the elevator will go up to 4 and stop, and also the LEDs are changed. And then let's say I go up to, this is 12, it'll go all the way up to 12. And stop. And let's say I try to press 12 again, nothing happens because it's still at that floor that you want to be at. And so now if I go down to, what is that, 6, it'll go down to 6. Also the LED display is changing. And then last we'll go down to floor 0. So we'll go all the way down, stop at 0.